back looking at the TodoMVC example. I'm going to add a few items, foo, bar, baz, pat, and I'm going to check 2 of them. The feature we're going to look at now is this one. We have all active and completed, and these are filters, so when I click active I only see the ones that are not done, and when I click completed I only see the ones that are done. But it's not just that. If we look in the URL, you see here there's a hash, there's a completed. If I click active, same URL with a hash, but now it says active. These that look like buttons are actually styled links, anchor tags, which takes you to this URL. When you go to a URL that's the same in all but whatever comes after the hash, it doesn't reload the page in a browser. So that allows you to use the back and forward buttons within a single page application without actually reloading the whole page. In other words, it's a basic example of routing, and that's what we're going to look at now. Let's start with adding the links. We'll need a footer, we'll need ULLI as a list of the links. We'll need a, that's enough. After the item list section, we'll have the footer, which will have a UL with the class, oh, forgot the comma there, with class filters. And each filter will be a list item and a link with the text. Let's do this one all. Now let's change. So we have one that's all, one that's completed, and one that's active. Okay, here we have them. They don't go anywhere. They're just links with no addresses for now. Let's change that. href hash. This one is hash completed, and this one is hash active. Okay, so when we click completed now, you can look in our URL, we have hash completed. When we click active, we have active, and when we click all, we have nothing. It's equivalent to that. But now we would like to know which one it is visually here. That means we need to respond to changes in the URL here after the hash. Now Hyperapp doesn't have routing built in per se, but it has a more fundamental concept called subscriptions. Subscriptions are for any time you have an external event source, whether that be WebSockets or a timer, or in this case, the location object. It lets you manage listening to external event sources like that in a declarative way, very similar to the view. So you could say, I have this subscription and I have that subscription, and Hyperapp will start these subscriptions for you. It could have state foo equals bar, and so you can have logically conditioned subscriptions too. This is very similar to how the view is declarative when you think about it. Every time the state updates, we define a new shape of the view. Hyperapp isn't just going to tear up all the DOM nodes that are already there and make new ones. It's going to compare what we asked for to what's already there and only make the changes that are necessary. And in the same way here, every time the state changes, it's going to run this function to get a list of the subscriptions that we want active, and it's going to start the ones that need to be started and stop the ones that need to be stopped. So in this case, subscription 1 is going to be started right at the beginning of the app, and it's never going to be stopped because it's always there. Whereas this one, whenever state value foo changes to bar, it'll start the second subscription. And whenever it changes away from bar, it'll stop it again. This is really helpful because it means you don't have to manually manage a bunch of listeners, keep references to them, and keep track of when it's time to start and stop them. But what is a subscription? It's actually very similar to an effect. It's a function and it's an options tuple. And similar to effects again, this function takes dispatch as its first argument and gets the options object passed to it as a second argument. And what this function is for is this is what Hyperapp calls in order to start listening. So here you define how to start listening. The only difference between subscription functions and effects functions is that subscription functions are expected to return a function which Hyperapp can use to stop listening to the same subscription when it determines that it is time. So this lets us define how to start and stop listening to external event sources based on a bunch of options. Of course, it's not okay to have the function inline like this because Hyperapp has no way of knowing that it's the same function. Anonymous inline function like this have new references every time they're defined, even though they represent the same operations. So let's refer to a named function on hash change, which is what we care about. Const on hash change. And how do we start listening to it? Well, we add event listener to the hash change event. And what do we do when the hash change event occurs? We dispatch some action, the options action, with the location hash, let's say. That'll make it easy. And to stop listening, we remove event listener hash change. And again, we can't have a anonymous function because it won't be recognized, so we need to define it. Const handler equals this, and we'll use it here. Handler. There, okay, so now all we have to do is pass an action in as an option. State hash. And let's just say that we return the same state as before, and we set the filter to if the hash is equal to hash completed, then the filter should be completed. If the hash is active, then the filter should be active. And if it is neither of the above, it should simply be all. So we can add another filter value to this initial state, and we'll leave it at null to begin with. Whenever the hash changes, it's going to be updated. So we could add a current class to each of the links so that they will be highlighted as the current one. In this case, it's going to be current when the state filter property is all. And copy that. And this one when the state filter property is completed. And this one when it's active. Let's try it. So when I click active, it should change the URL, which should make our subscription dispatch the action, which sets the filter to active, which should set the class of this link to current, which should show up because I have CSS for that. It worked. But now look what happens when I reload the page. Of course, filter state is null to begin with. And if I click the active link, the hash isn't changing, so the event doesn't dispatch. It would be kind of nice if we could dispatch the action right when the app starts up so that we could see right from the beginning which one was active. You might think that calling handler here would do the trick, but don't do that. That's going to give you an infinite recursion, because what happens when you call handler is dispatch. The action is called, which is going to change the state, which goes into Hyperapp's internal state update operation. Subscriptions are patched and started or stopped in the same tick as the state update operation. So that means that even before we are finished starting this subscription, handler is going to be called, dispatch, that's going to mean a state update. It's going to go see that, okay, we need to update the subscriptions. Oh, here's one that we need to start, and it's going to come right back into this function without ever exiting it the first time. And it's going to go into handler, and the whole thing's going to start over and over and over. So the way to get out of that loop is just to defer the call to handler somehow. You could use set timeout, a microtask. I'm just going to use request animation frame. There. I'm going to set completed to active. And if we reload it, it stays that way. Set active. It stays that way. Okay, now we have routing basically set up. Let's just try to clean this up a bit. Let's move this action out from being an inline action. Let's call it hash handler. And let's define it. Const hash handler equals this. Also, let's make a nice interface for this subscription. It's just similar to what we did for effects. We say const on hash change equals just needs an action, and then we can return the tuple. hash change action. That way the subscription can simply be on hash change hash handler, and everything should still work. Now this of course belongs in our lib.io module where all our effects and also subscriptions belong. And let's move all this filter menu stuff out of the index file just like we've done for the other things. New file filters.js. Let's export const init null. Export const wire. Should take a get and a set. And this is where we can define the hash handler action. So it's simply set state and then this ternary condition with none of the other junk. And it returns an object with the model state, and we have the filter, which is going to be simply get state, and it has the hash handler action. Now let's export const menu. Let's call the menu the view that we want here. It's going to take the model, and means we can take all of this out of here. Of course, it doesn't have the state anymore, it's the model. And let's also export the subscriptions. Also based on the model, but it's an array, and here we say on hash change model hash handler. Now we need to import these things, of course. We'll need to import the ULLIA text from at Hyperapp HTML, and we'll need to import the hash handler from .lib.io.js. Wait, no, on hash change, of course. I realize I made an error here. There we go, and in the index file now we can get rid of these imports. We can import star as filters from filters.js, and we can say const filters equals filters wire get state filter set. If we have a new filter, we set it on the app state. Here we can use whatever filters module wants us to init with. In the footer, we're going to use the filters menu, which is going to take the filters model, which is a function of the state. And in the subscriptions, we will use filters subscriptions, which needs the model, which is a function of the state. There we go. The index file is still clean and abstract, and it should all still work. We reload and we have completed. Click active. Now, of course, we haven't gotten into filtering these items yet. That'll be the topic of the next video.